Hello, everyone. You're welcome to this class. In our last class, we calculated the load on beam one as 35.55 and 40.393 kilonewton per meter square. Today, what we'll be doing is calculating for the moments at each support using three moment equation, that is Clapeyron's three moment equation. But a lot of people, or most people, use Hardy-Cross method, but I prefer using three moment equation because for me it's very easy and accurate. All right. Now, if you want to make use of this three moment equation, we consider the support 1, 2, 3, 4. All right. At span A, B, and BC, we have three supports. Okay. Now, recall that at the outer support, the moment is equals to 0. So, first thing first, I have to bring in the formula here. At span A, B, at span A, B, and BC, the three moment equation is as MA, as the moment at support A multiplied by the span LAB, alright, plus at B we have two spans, span AB and span BC. Alright, we're going to say 2MB into LAB plus LBC plus, you see how BC here, moment at B and C, MC multiplied by LBC, or you can call it LCB. All right, this one now will now be equal to the load WL raised to the power 3 over 4. All right, this is three moment equation. That's the formula for three moment equation, where MA is the moment at support A, LAB is the span at A and B, between A and B, then 2MB, now the support. All right, there's a moment here, there's moment like this, and there's another moment this way. So 2MB so LAB plus LBC plus MC LBC multiplied by that. So then at span we have BC, at span BC and CD as well. The moment equation now, we are now moving away from here. We are now talking about BC and CD. All right. The formula also will now be L, that's MB, multiplied by LBC plus, look at it, moment 2MB, 2MC into LBC plus LCD all right, then plus MD multiplied by LCD equals to WL3 cube over 4. All right, this is the formula for solving three moment equation. Then, assuming the beam continues beyond D, E, F, G, you continue like that. So when you are now dealing with, when you are now moving ahead, That's to talk about the span between C and D and E. You now come here again. You will now say M C L C D plus 2 M D, just like that. All right. Then at the end of the day, you will now solve using simultaneous equation method or determinant method. All right. Now, but for this, let us proceed. Okay, we have gotten the two formulas for AB and BC, then BC and CD. So we will now proceed by imputing the values. Okay. Now we now move for the span AB at span AB at span A, B, and CD. We'll have that the moment the equation will now be three-moment equation will now be, at outer support, MA is equals to 0. MD is equals to 0. It means that MA is equals to MD equal to 0.00 kilonewton meter. All right, 0.00 kilonewton meter. That's for MA and MD because this is at outer support, they are equal to 0. Now we'll now move to at span A, B, and BC. We have MA multiplied by the span, which is 2.250 plus 2MB into LAB is 2.250 plus LBC equals to 4.1125 plus MC multiplied by BC, which is equal to 4.1125 equal to WS cube over 4. Now we now have two span here. Now BW, this W 35.55 over 4 multiplied by 2.25 raised to power 3 plus 40.93 over 4 multiplied by 4.1125 raised to power 3. This will now be our equation 1. After computing these values, you recall that MA is equal to 0. So the whole of this will now be equal to 0. So we will now rearrange. There are 2 MB now. When you compute this and this, please let's quickly use computer to calculator. 2.25 plus 4.1125 will give me 6. Multiplied by 2. So 2 times the whole of this number will give me 12.725 MB plus MC will now be 4.1125 MC is equals to, when you compute all this, you are going to have a value 35.55 divided by 4 multiplied by 2.25 raised to power 3. So that will give me 101.23 approximately plus 40.93 divided by 4 times 4.1125 raised to power 3. This one will give me 711.70 approximately. So if you add these two, I'm going to have a 12.725 MB plus 4.1125 MC is equals to, add these two together, plus 101.23. We have 812.93 approximately. This one will now give me equation 1. This one will now be equation 1. Okay, I've gotten this as equation 1. So we'll still proceed. We'll still proceed. Okay, we'll still proceed. Now, at span B, C, and CD. All right, that is where we are heading to now. At span BC, and CD, we now have MB, that's MB 4.1125 MB plus 2MC into 4.1125 plus 41125 plus 41125, then plus 4112 MD, 41125 MD is equal to, now from BC and BC and CD, we only have this load. All right, we only have this load. So we will not have 40.93 over 4 into 4.11253 plus 4.11253. Okay, so when you solve, you are going to have bringing this one down, we'll have 4.1125 MB plus this. All right, 4.1125 times 2 times 2. I have 16.45 MC is equal to, all right, is equal to, when you compute the whole of this one, you are going to have 4.1125 raised to the power 3 plus 4.1125 raised to the power 3 plus 4.1125 raised 3, then they multiply by 40.93 divided by 4. This will give me 1, 4, 2, 3.41. This is our equation 2. Equation 2. Alright? Yeah, we have gotten this equation 2. We can now rearrange. Alright? We can now rearrange. You know, we have equation 1 here. So let me clean. So we have rewriting equation 1 and 2. Have 12.725 MB plus 4.1125 MC is equals to 812.93. This is our equation 1. Alright, then equation 2 we have 4.1125 MB plus 16.45 MC is equals to 1423.41. This now becomes our equation 2. Alright, so we have solved for our equation 2. Then in our next class, please, it's becoming too long. So in our next class, we'll solve for the moments at the supports, then the moments at the span as well. Alright, this is how to get your moment using three moment equation. So we've been able to, arrange the equations, equation 1 and equation 2. So simultaneously, using simultaneous equation, we can now resolve MB and MC. Or to make it neater, we can use determinants, okay, to solve for MB and MC. Thereafter, we now move to the span moment to calculate for the span. Thank you very much and God bless you. This is all for today. Thank you.